Hello everyone, welcome to my YouTube channel. Thank you so much for your amazing response. You know, I started this quantum computing series. I'm doing regular videos on certification path. I've done 3 episodes on quantum job roadmap, which I will be continuing. I got so many questions on the quantum B.Tech course. Now that you all know, so many universities, private engineering colleges, they are starting this quantum computing 4-year B.Tech course. So I got questions from students. Sir, can you please let us know what is the use of this course? Especially those who are in intermediate stage, 10th class, who are planning for their B.Tech. They were asking me that if we do B.Tech in quantum computing, will it be useful? So I am not the correct person to tell whether it will be useful or not useful. That is your judgment, your parents' judgment. But the only thing I can say here in this video is all about the way the course is structured. I have surveyed all the university curriculum, their courses. That means I have surveyed all the university B.Tech quantum computing syllabus. I prepared one gist for you to know what exactly will be there in quantum computing B.Tech course. After listening to this video, it is your decision to take quantum computing B.Tech as your career path or choose something else. See, ultimately, the student should be interested in selecting the course. It is their own interest. For example, if I want to be AI engineer, I will take B.Tech artificial intelligence. If I want to be data science engineer, there are some universities, there are some private engineering colleges which are providing B.Tech data science. So in that way, I have some vision. I have to fulfill it. For that, I join one course which will correlate with my vision. That is what my idea is. Having these many years of experience and being the mentor for so many students, this is what my feeling is. So you judge after listening to this entire video, which will be just for 20 minutes hardly. You take the decision whether you want to join this particular B.Tech quantum computing undergraduate course or not. Okay. So not wasting your valuable time, I will come into the actual thing. See, as I told, I surveyed several curriculum, course structure, and after that I am doing this video. Here, every generation has its defining technology. That is an acceptable point. That is an acceptable point. There was electricity, then electronics, then computers came. You know about von Neumann machine in 1950s, 1940s, right? That was classical computer. Now it's quantum. People are talking about quantum. So quantum computing isn't just a faster version of classical computing. It's a complete reimagination of how the universe processes information. Okay? You know that traditional computer deals with bits, zeros and ones. Quantum computer, it uses qubits, which can be both 0 and 1 at the same time. So that is what is superposition. So when qubits interact, they get entangled, which is nothing but a mysterious connection. Einstein once called it as spooky. And that spookiness is exactly what makes quantum computers unimaginably powerful. So problems that take supercomputers can be solved in seconds. Once again, I will repeat. Problems that take supercomputers years can be solved in seconds. This is the world, the new B.Tech in quantum computing prepares for you. Right? It's not a typical engineering course. It is the course where physics meets code and mathematics meets imagination. Once again, I am repeating, physics meets code, mathematics meets imagination. I am going very slow so that you hear every point and digest it before taking the decision. See, your B.Tech course is for 4 years in India, right? So your journey begins with building a foundation. So students start by mastering mathematics. In general B.Tech curriculum also, we do mathematics. For computer science, mechanical, civil, we do mathematics. But here, our focus will be not on just equations. Here the focus will be on the logic that governs all the systems. You have to learn physics deeply, concepts related to light, energy, thermodynamics and nanomaterials. This will be your curriculum. I have surveyed several university curriculums, I already told you. After that only I am doing this video. Right? So the quantum world is built from these principles. Then comes electronics. So understanding how every diode, transistor and microchip behaves will be part of your curriculum. Along with that, you will be learning programming, that is compulsory. You will start using C. You will be doing computational thinking from the ground up. And then you will be entering into the first real spark, that is fundamentals of quantum mechanics, where you will study about waves, uncertainty, probability, and the mathematics of the atom. From there, the course evolves into computing and logic. Students will be moved to linear algebra, calculus, digital circuits, and data structures. Right? So you should be learning in terms of logic gates and algorithms. But at the same time, as a student, you will be entering the realm of quantum theory, where information behaves probabilistically and reversibly. So this is your travel for first year. In first year, you will start relating electrons in a circuit to qubits in a quantum register. You successfully complete your first year, you build the foundation. Then your second year, which is a bridge for your entire 4 years course, it will bridge classical systems and quantum systems. So as a student, you will be exploring Python programming, probability and statistics. So there, the language of data and randomness that quantum relies on will be taught to you. You will be studying signals, systems and electromagnetism to understand how information travels. As a student, you will be exploring quantum hardware and the methods used to correct quantum errors. Right? And some universities I have gone through, they are giving complete hands-on with platforms like IBM Quantum and QSkit. There, you can code real quantum algorithms and see them execute in the cloud. That is one of the important part. You check, you do your survey. I will keep some university curriculum links also in the comment section. Right? Whichever suits your interest, you choose that. So here, where I was telling about the quantum algorithms being executed in the cloud, that is the point where your imagination turns into experiment. Without experimenting, you can't learn anything. Then comes deep quantum stage. You will learn about quantum materials, quantum algorithms, and quantum networks. Okay? So students will be made to learn about concepts like entanglement, teleportation, and quantum game theory. I have posted in LinkedIn very concisely and in a easy manner about these concepts. You can check my LinkedIn profile. There I have already in my wall page, these concepts are posted in a simple way, just for your basic understanding. Right? So as a student, you will be exploring how information is transmitted, how algorithms like Grover's and Shor's work, and how these ideas are reshaping cybersecurity and cryptography. That is also taught to you. And you will have some specialized labs, building circuits, simulating quantum systems, and you will be applying theory to tangible results. Right? So it's not just equation on paper anymore. In second year, you will start doing real world implementation. Right? So I have studied all the syllabus, and my way of analysis tells that every syllabus of quantum computing from every private engineering college and government universities, they are mainly focusing on lab work related to electronics, computing and quantum systems. You will have internships where you can go to certain industries and do some work. I will do a video on where to go and what to do. You please wait for it. And then you will be directly connected with some research centers, startups, and you will be exploring quantum technologies. Right? So by that time you enter the final phase, you will be not a learner, you will be innovator. That is the way the courses are being planned. Right? So in this way, I just consolidated second year and third year in general way. I did not specifically go for 2-1, 2-2, 3-1, 3-2. I started with second year, but I consolidated second year and third year in general way. I don't want to be more specific in this video because that is what is not my agenda. I want to be concise and give you the exact details. Then comes your opportunity to choose electives. Right? In some universities I have seen some autonomous universities, what they are doing is they are giving lots of electives as selection. So there you can choose quantum simulation and chemistry, quantum A. Those who are interested with artificial intelligence, you can combine the quantum favor with A. You can also choose sustainable energy systems, industrial automation, and even quantum cryptography. So electives means it's your choice. Depending on the university and the staff available, they will make you select certain subjects. We say courses. So each subject, if you see, it opens a new door. How qubits can discover drugs faster, how sensors can detect molecular changes at unimaginable precision, and how quantum communication can make data completely secure. These are the things which you will be made learn in general. So I have seen some universities, they are focusing on building startups and connecting with industry experts also, which is a good job. And students, if they join those kind of universities or engineering colleges, they not only learn science, but also the tools, platforms, and collaboration skills needed to turn their ideas into working technology. That is very important. See, these are all the things in general I spoke, not taking any particular university into consideration. But one thing I want to tell you is the ultimate test comes when you do your project. I will do one particular episode on the way to select the B.Tech project, especially in quantum computing. I will do it. Here I am just trying to give you some pointers. You have to design algorithms, you have to develop applications, you have to conduct experiments that contribute to real research. And you are the part of global learning. You are no more a local student. So each student should complete an online MOOC from leading universities like IITs, so that you can keep yourself aligned with international standards. or else some abroad university also you can choose if they are providing. After 4 years, you should not be coming with a degree, but you should have a mindset capable of transforming industries. Then only you can sustain in quantum computing. Not only in quantum computing, you take any technology. So, if you complete this, what jobs are there? I am already doing the series of quantum computing jobs, which I will continue. I will not stop it. I have done 3 episodes. I will put those links also in the comment section. You can check them. Right? You will work in quantum software, hardware, AI quantum integration, cryptography, research institutes, even entrepreneurship also you can do. Entrepreneur, how to become entrepreneur also, I will put a video on that. So you can join labs, you can build your own venture as I already told, right? You can grow to the level where you can have multi-trillion-dollar global industry also. People are doing that. I'm doing such kind of podcasts with those kind of CEOs also. You can watch my channel. So quantum computing, finally, a person who is very much interested in this area, if join this course, definitely you will have a good kind of shift, bigger than any before it, that I can confirm. Once again, I'm telling you, it is not about faster processing. It's about redefining what computation even means, right? So if you start learning it now, you will be the future architect, right? So here I want to tell you, you should have love towards math. Please understand. You should have love towards physics, coding. And then only you please join this course, because this degree doesn't just teach you subjects, it teaches you a new way of thinking. Right? How you can change the world. How the quantum revolution, which has already begun, can be moved forward by you as a student. So what I want to tell you is here, your journey is very beautiful if you are very much interested towards physics, mathematics and coding. So my conclusion in this short video is, do join quantum computing course. Once again I am repeating, if you love physics, mathematics and coding. These are the 3 important aspects which will be there in every course which I have surveyed. You can also do survey of your own and take the decision. My survey is my own survey. Your survey can be different, right? But on a whole, this is the gist. Okay? So I hope this video will help you, and definitely it will make you understand what the exact quantum computing B.Tech course is all about. I also suggest the parents of children to see this particular video so that you can also take decision. In the sense, you are not the person going to take the decision, it's ultimately the student, but you can help them in taking the decision. No problem in helping the student in taking the decision. Rather than pressurizing them, you can just give your own insight as well. So thank you all. Wish you good luck. I am seeing lots of quantum revelation across the entire country and globe. So that is the reason why I have thought of making this video after so many queries from students. And hopefully it will be helpful. Thank you all. Have a great learning. Bye everyone.